Welcome to the Orange County Forum, where newsmakers keep you informed about local, national, and global issues that impact Orange County today.
It is a great pleasure for Exxon Mobil to have an opportunity to come and talk to the Orange County group and really share our views. Energy is obviously important to us. It's our business. And, that just goes without saying. And so what is an energy outlook? Well, we spend a significant amount of time every year preparing one of these. We do this as an internal analysis of what's happening with long-term energy trends because of the business that we're in. And we want to make sure that we understand to the best of our ability where we think things are going to go. And so what I'm going to take you through is our view of the future of energy out to 2040. And it's our best analysis and data-driven approach of where we think trends will take us. We invest about $38 billion a year in Exxon Mobil and of our shareholders' money. And so we want to make sure we do it on the best information we can. The first step is just a little bit about the outlook. The outlook is an individual country outlook that's added up to a global total. So we do a U.S. outlook, we do a China outlook, we add all these pieces together and we have an energy outlook. We study the kinds of energy people use and how they use them and what are those trends. We also study policy because it's important to understand policies, how they're going to affect energy use in the future. And one area that policy impacting the U.S. significantly now is vehicle efficiency policy. One of the other policies that we take into account, and we have for a number of years, is carbon emission policies and how they affect energy use. We're not proposing a particular policy, but we do recognize that over time, governments will take on an increasing position of managing greenhouse gases and CO2 emissions and carbon emissions, and so it's only prudent for us to include that in our outlook. And this map shows over time that we have adapted a variety of policy price assumptions. I have no idea what kind of policy will actually be adopted, but as technocrats, we have to be able to model it with economic models. And so we use a proxy cost of carbon, and we have it increasing over time, first in the OECD economies, and then later, after 2030, in the developing world economies. And if you understand global emissions, you know that without involving the developing economies, you really won't be able to have an impact on global emissions. First, we have to build a population and an economic forecast. Now, we rely on UN and World Bank data for population forecasts. We develop our own economic forecast. Globally, the world population is going to add about 2 billion people. About 95% of those are in the developing economies, which I show in red on this chart. On the left, we reach almost 9 billion people by 2040. 95% of that increase, that 2 billion from here to there, from 2010 to 2040, is in the developing world. Now, in the middle is our economic forecast. That's our own in-house economic forecast. Globally, we think the world will grow about 2.8% from 2010 to 2040. The red, the developing economies, will grow faster. I'm going to talk about those in more detail in just a second. And the blue are the developed economies. We expect to see about a 2% growth on average over this time period. Now, one of the things I'll say about long-term average growth rates is they tend to mask ups and downs. We're still recovering from recession. There'll be times when it will grow over 2%, when it'll grow under 2% on the world average. The right chart that I just put up there is energy demand. Now, the world economy is going to more than double in this time period, going up about 120, 130%. But energy demand is only going to go up about 35% because of efficiency and other trends. If it grew at the same rate as economics, that black line would say we would need significantly more energy than what we do. The blue section on that chart at the bottom, the developed economies, the OECD, they do not show an increase in energy demand. Despite a significant increase in economic output, we don't see energy demand increases in the developed world. Changing energy mix, yes, but absolute energy increase, no. Where we see it is in the developed and expansion economies. Today, of that, in terms of today, 7 billion people roughly in the world. 1.5 billion people don't have access to electricity, and they don't have, over 2 billion don't have access to modern heating and cooking fuels. And that level of development, part of this increase in energy will go to raise, and economic output will go to raising their standard of living. Let's look at those economies a little bit more detail. Here on this chart on the left side, it's all these stacked colors. China and then India are on the bottom. They represent more than half of the growth in the economic expansion during this time period. If you look on the right, that's their energy demand forecast. And you notice what's happening with China is it's plateauing. And then energy demand growth in other sectors. China is going through an interesting phenomenon. China is trying to shift its economy from an investment-driven economy to a consumption-based economy, very much like the U.S. is. Now, they'll have still higher growth rate because of other factors, and that is part of the reason that we expect their economy to slow down. The other reason, their population is going to peak and start to decline slightly. More importantly, their working age population will start to decline later this decade. It's a well-known expectation, and that's going to change China's energy use, its economic output, and how it functions. So that's one of the reasons China is going through an effort to change. Everybody thinks of China as this huge growth and it keeps going. Well, it will keep going, but it's going to change and be different. And so for us to understand the future of energy, we have to understand each one of these country or these country groups in pretty good detail so we can assess where they're going. And so this is the type of things that we consider when we go through this. Now, this is the U.S. U.S. population shown on the left is growing. In the middle is our economic output forecast, a little over about 2.3% on average, a little faster in the front end, a little slower in the back end. And then the energy demand is shown there on the right, and it's very stable, actually declines slightly, but for all intents and purposes, energy demand in the U.S. is flat. We study energy in four major groupings of use. Electricity demand, which is a fascinating topic. Industrial demand, transportation, and residential commercial. The last one is where we live and work. The one in the middle is pretty self-explanatory, transportation, because that's how we move things around, things and us. And industrial demand. And electricity demand is where we study the fuel for electricity. But actually, electricity is used in residential commercial applications and industrial applications. It's about half and half. But overall, electricity generation is the largest energy use today and in the future. More than 40% of our world's energy in the future will go to electricity. More than half of the increase in energy demand between now and 2040 will be in electricity generation. So it's no wonder one of the most common topics when people talk about energy is electricity. So there's four major groupings within industrial. Chemicals, big section of industrial demand, large growth area, very commonly understood to be plastics. Fertilizer is a chemical, paints, any number of chemical products. The manufacturing and industry segment is where you see things like steel being produced. Cars are made from steel. What else is happening here in manufacturing industry is cement. Cement plus steel equal infrastructure. And we see that in roads, in railroads, in buildings, in power plants. So what that rapid energy demand increase in all those developing economies I mentioned earlier, a lot of that is to build out of infrastructure, as they also build factories, create jobs, create employment, rising standards of living. All of that goes in with that. The energy industry is not just my business, it's the coal industry, all sorts of energy activities, but that's where we capture how much energy we use. And we don't see a big increase in energy demand there. And other is predominantly agriculture and some other niche industries. The first two, chemicals and manufacturing, represent 90% of the industrial demand growth in the world. Now, let's talk about the U.S. Industrial demand on the left, commercial residential demand is shown on the right chart. If you look at the blue segments here on the left, the chemical industry and the heavy industry, those two in the middle, are growing through the middle term of the outlook. We see an increase in demand because of increased use of natural gas and other supplies in larger chemical applications, more industry in the U.S. It declines not because we expect industry to leave, but more because of efficiency over time. And so overall, we see this sort of growth in the middle and then a slight decline. Residential demand on the right is fairly stable. It actually gets a decline slightly, more efficiency in homes and such as that. In the commercial sector, because of rising economic progress, we see more expansion in commercial business. That's also where some of your service sector businesses fall. And so we see that overall mix combining to be a fairly stable group, but some movement in the pieces in the middle. It's always important to look at the overall and the pieces. Let's talk about transportation. The big story in transportation is trucking. shipping. That represents commercial transportation. Commercial transportation is the largest growth area in transportation fuels going forward. If you look here on the left, this chart is in million barrels a day of oil equivalent. Why? Because liquid fuels are dominant in transportation. The light duty demand on the bottom, this is global, will actually grow a little bit and then plateau out and be flat. No more incremental growth there, despite a huge increase in cars. Heavy duty demand will actually grow, as will aviation, marine, and rail, reflecting economic output. There's a lot of efficiency across all this, and that's actually what I'm going to spend most of our transportation time talking about. So, transportation fuels, big deal, because this is a significant part of energy use today and in the future. It's up about 40%. Asia Pacific, shown in red, will double its transportation fuel demand over this outlook period. Now, North America, look at the blue. It's pretty well stable down a little bit. Actually, we see U.S. transportation fuels declining, and I'll show you that. Europe is in the same situation. This is that developed economy phenomena where transportation fuels are fairly stable and growth in the expansion developing economies. And so this is the phenomena. China will be the second largest transportation fuel user by 2040. Energy density. Why is transportation fuel predominantly liquid? Motor gasoline and diesel are the most energy dense. What I mean is there's more punch in there. Ethanol and LNG are less dense, but still in the same range, but they're down at the lower end. So when you add ethanol to gasoline, you get a lower density. And CNG is about a third of gasoline, and electricity on a per weight basis for batteries versus gasoline is less. This is U.S. transportation fuel. On the left is million barrels a day of oil equivalent, and on the right is the vehicle fleet. The U.S. transportation fuel declines. Light duty, personal cars is down about just under 3 million barrels a day, and we see increases in the other categories, but not enough to offset the overall decline. So U.S. transportation fuel is going to be declining over the outlook. The U.S. has one of the largest penetrated vehicle fleets in the world, and it approaches about 300 million cars by 2040. The colors in that panel, the green on the bottom, conventional gasoline, the light blue is hybridization, that wedge in the middle is conventional diesel, and then we have plug-in hybrids and electrics in the purple, a little bit of CNG and LPG in the top, just to get you oriented to the chart. The conventional gasoline engine will continue to be a major part of the vehicle fleet, but over time, hybrids will replace that as the primary vehicle choice. Now, that's a phenomenon that we think is happening in the world. We get to about 50% hybrid and other advanced vehicles, and this similar level for gasoline and diesel by 2040 in the fleet. This chart is new vehicle sales, not in the U.S., but around the world. They average right now probably in the 75 million vehicles per year. They reach about 130 million vehicles per year, 120, 130. China is going to be buying 35 million of those every year. That blue is the hybridization. Hybrids sell more because after about 2025, we think the battery economics and everything come together to make them more economical. You see an increase in the purple, which is the electric vehicle, the plug-ins and other electrics, as also costs come down and they start to penetrate. Now, it's not just in cars, it's in trucks too. I'm not going to go through the left in great detail, but you add those two red bars up, and from 2010 to 2040, we're going to see a 50% increase in the truck efficiency of a heavy-duty truck. What that means is when you look at the right, which is energy demand for heavy-duty trucking, you avoid about 25% of the potential energy demand for heavy-duty trucks because of that improvement in efficiency. And that's a really important component of looking forward. And this is a result of manufacturers doing new things. The reason we broke that into two pieces is because we're going to adopt it in the OECD, where we have evolving policies and more penetration of the vehicles, and then it migrates around the world and into the other fleets. So we actually go through this type of analysis, country by country, thinking through this, and so it's a very data-driven exercise. But these are the types of learnings that we come out with. The other thing we did this year is we added in an analysis of long-haul trucking and whether or not we were able to get LNG and natural gas into truck shipping. And we think LNG will fit into long-haul shipping, and we think CNG will be more for local deliveries. You see it in buses, delivery, fleet vehicles that come back to the same location. So we think that we will see an increase in natural gas use over this time period in transportation. Electricity generation. 85% increase in electricity we need. Now, this is that same division between the two different groups, the developing economies on the left, the developed economies on the right. 150% increase in power generation requirements in those developing economies. Rising standards of living, greater industrialization, all of those things occurring. On the right is the developed world. We see an increase in electricity demand. We've electrified just about everything we need. We have air conditioning in most places that we need. But we find new ways to use electricity. You don't think much about it. And I'm not necessarily talking about charging the device. Think about the amount of information you move over it now. 10 years ago, you weren't streaming a video. Now, people sit around and watch the news on it. 20 years ago, it was just a phone. And you know, so the amount of information that gets moved is one of the demand sources in those server farms and internet access and all that stuff that's going on. So all these things, these advantages, these quality of life elements are heavily impacted electricity use. So where do we get electricity from? We get it from generation types. Now this chart shows what kind of generator is going to be producing the electricity. If you look on the left side of this chart, at the bottom, we have other renewables. That's hydro predominantly, some geothermal. Wind and solar are growing. Nuclear grows a little bit. Coal grows, but then sort of plateaus. And gas grows. This is one of the things when we say we think gas is going to play a larger role in future energy supplies, it's because gas generation is going to be up. And so we see about 40% of the world's supplies coming from renewables, wind and solar, and nuclear, and the rest being split sort of evenly between gas and coal generation. This chart shows U.S. costs for electricity. It's in cents per kilowatt hour, and basically it shows what a theoretical power plant would charge into the grid for electricity on a levelized basis in 2030. Coal, because of policies, would be the most expensive. Then gas and nuclear would be in there. These are base load. They're there all the time. They're the ones when you turn the light switch on that generates the electricity. The other ones, wind and solar, are intermittent, and they're there when they are available. If you just looked at their pure capital costs, that's where you would see them lay. But because of their intermittent nature, you have to have additional investments in reliability support. And that's one of the areas that we have to recognize that that's a cost that's often not understood. And we think there's more work to be done there. We know some academics are doing it. The OECD itself actually put out a report earlier this year on that. It's an area that gets more attention. This is the U.S. electricity demand on the left, supply on the right. I talked about the mix. What I really want you to do is look at the shape of those curves. The curve on the left is up over 20%. The curve on the right is almost flat. It's up about 5%. Because of the efficiency shift, by shifting to different types of generation in the energy mix and better efficiency, we're able to generate more electricity with less fuel in the U.S. That's one of the areas of efficiency. Gas, combined cycle, 60% efficient in a baseload application compared to maybe an older coal plant or some other facilities. And so we see higher efficiency in the U.S. generation mix, and that's an important part of that, keeping the U.S. energy flat. This is the same chart on the left. The middle shows how the mix shifts. I won't go into the detail. What does happen, though, is we see lower emissions coming out of U.S. generation, about 40% less when you compare 2040 to 2010. An important trend that we see across the developing economies. Overall, if you look at the individual sectors in U.S. demand, transportation, electricity generation, industrial, and residential commercial, you can see the relative shares. We use more energy in the U.S. on electricity and on transportation than we do the other two. On the right, the fuel mix. Our oil demand is declining in the U.S. We do think gas demand will grow, coal will decline, and we see growth in renewables and some growth in nuclear. If you look at the world, this is what we call sort of the tale of two worlds. The developing economies on the left, it's sort of more of all. But in the developed world, again, it's sort of like the U.S. story again. A decreasing oil demand, increasing gas demand, increasing renewables and nuclear, and decreasing coal. This is how the policies play out and the economics play out in each one of those countries that we roll up. So when I said the world is up 35% in energy demand, it's really up about 60-65% in the developing economies. It's flat in the developed world. So I've got one chart on emissions just to put that piece together because we do have to consider that as one of our assumptions. And here we see the OECD emissions in blue are declining over time, and the non-OECD continue to grow, but China starts to slow down. Those two things combined show emissions starting to plateau around 2030. And that's a trend that we've identified over this last couple of years. We added the 2040 extension to our outlook 2 years ago. In 2040, 60% of the world's energy supply comes from oil and gas. Fossil fuels have traditionally produced somewhere over 80% when you include coal, and that's where it is in this range now, and it declines a little bit, but still we're up close to 80%. Again, I'll remind you, this is not what we wish would happen. This is what we believe will happen based on the analysis and the data and the buildup that we've gone through. So here we show a ranking and a stack up of all the energy supplies. Oil will be largest. Gas actually increases the most, up over 60%. Coal peaks and declines. We see growth in all the others. I'll point out solar, wind, and biofuels, the modern renewables, as many call us, in that next to the last bar. You see that dashed line at the bottom? That's where it is in 2010. Significant increase in output over that time period, growing on average about just under 6%. But if you look at wind and solar individually, they're up over 7% annual growth. So much faster growth than any of the other sources out there. I'll talk about supply for a couple minutes. And today, the IEA reports, I think, oil demand, liquid demand is around 89 million barrels. It's going to grow in our outlook to about 113 million barrels a day. The green is what we'll call conventional crude oil. From a technology labeling standpoint, those different slices above have used different technology to access them. Deep water. Tight oil and oil sands are unconventional resources, as we call them, which means they require a different set of technologies to access. Natural gas liquids, NGLs. I'm sure a number of us in here have used propane in a grill. Propane is a gas liquid. When you produce natural gas, you get a combination of products. And so gas liquids come with gas, and they're part of the liquid equation that goes into this. They go into the refining system, they're used, they're in the chemical system. All of that occurs in there. Other liquids, biofuels, those grow a little bit too. So the point I'm making is that the shift and growth in liquid supplies is really starting to occur outside of what that conventional supply base looks like. The bar I put up on the right is a measure of total resource from the IEA. And if you take all the history of production and everything we have through 2040, we still have significant resources remaining in the world for liquid supplies. These three charts are parallel up here. They're all about the same height and bars and scale and everything else. And they show those different technology segments and how rapidly they grow and where they grow. And so there's significant difference in those different places, but North America is prominent in those, and so plays an important role. But technology, human innovation is what's bringing these resources in at a reasonable, affordable cost that allows economies to use them and continue to grow. Technology. We've always considered ourselves a technology company. Yes, we produce energy, but we're a technology company because of the tools that we use and how they change. And I just want to give you a sense of some of that development. If you look on this chart, this is a 12-year shift in seismic quality processing. In 2010, seismic was a bunch of lines, and we kind of knew how far the lines were apart, and the geoscientists and geochemists and geophysicists would, they would study that and say, well, this is how it moved and all that. And in 2012, they can actually see the density of the rock. Those colors mean different densities and components that are present, water and other things. They're able to get so much more information in just a little over a decade. How do you appreciate that distinction? Well, if you had a Mona Lisa of the original type quality, you'd just see sort of the lines that you see there, and otherwise now you'd see the picture. That's sort of the difference in technology in a decade. I've been in this industry for 3.5 decades, and I am stunned when I think about the changes we've made. Top right. Okay, even I have trouble seeing them. If you look in there, in that cutaway, in the middle of the bigger cutaway, there's these little parallel lines. Those are wells that are drilled from onshore this is in Russia, where we're drilling offshore 7 miles. And we're able to turn the well and penetrate the resource target with long-reach drilling. This is one of those developments. Horizontal drilling is what people throw around. The advances in that technology have just been stunning in what they've been able to do. But long-reach drilling is one way we work in some different environments. Crude oil processing, crude oils change all the time. Now, oil sands are going to be different than what we used to get in West Texas. So we have to adapt different processing so we're more efficient. So these are the developments that we see occurring all the time in technology that are important. So North America liquid supplies are changing and growing, and demand is falling. So that's an important development over the long term. If you look at natural gas, unconventional gas plays a larger role in North America, up to about 80% of our supply. If you look at a scale on the right, it's about 6 times larger, and there it's about 2/3 of the incremental demand growth in the world. Shale, this is the types of resource on the left and where it's occurring. Shale is the largest component, but not the only kind of unconventional gas that we're going to see in the world. Coal bed methane is out of Australia, tight gas is around the world. So we see significant developments around this. And so this is where technology and natural gas is playing a role. So the last chart here, let me just give you a quick rundown of history and the future. If you look at energy mix, this chart goes back to 1850, and it shows what kind of energy we use. We used wood for a long time. We switched to coal with steam because of the reasons I mentioned earlier. We discovered oil in 1859, but we didn't use it. We used it for lights because we replaced whale oil. It wasn't until the internal combustion engine, after 1900, needed a more dense energy source that we produced gasoline. Natural gas started to grow as we learned how to weld pipes and create long-distance systems. As you see in the top, we see nuclear coming in and modern renewables and other things changing the mix. Technology is moving through our energy mix, and it does it on an economic basis. When it hits an economic point, we see things penetrate. And that's what changes our energy mix in the future and what it has for the past. So that's the conclusion of the presentation. So thank you very much.
The Orange County Forum is brought to you through the generous support of the Orange County Register and our sustaining partners. For more information about the Orange County Forum, call 949-588-9884. The Orange County Forum is a nonprofit organization. Your contributions are tax deductible.